So this is just kind of a box. You can refer back to it. You have sine and cosine equations, and you'll notice for each equation, there's an A, a B, a C, and a D. So there are 4 things, 4 places where I can drop a number and change what it looks like. The A value always refers to the amplitude. So little a is referring to amplitude. Looking at a graph, you might take the maximum minus the minimum, divide by 2. Notice the amplitude, if you solve for little a, is always in the absolute value. So if I say what the amplitude is, you would never tell me it's -3. Okay? Always the positive number. B. The B value doesn't do anything for us except helps us calculate the period of the function. So B doesn't, we don't really use it for the graph. It tells us what the period of the function is. And that's always located in front of x. B is always what's in front of x. C, that goes with the phase shift. So let's write that down here. But notice what the phase shift is telling you. Take the quantity or the stuff inside the parentheses and set it equal to 0. Okay, so take the quantity inside, set it equal to 0. And then the last one is the D value, which really tells you where your midline is going to be located. So D is the midline. So for sines and cosines, you'll refer back to this box. It's got all the information in there just to remind you, but you do have to have that stuff memorized. The last thing that you want to look at where was I getting, pi over 2, and all those numbers? You take the period of your function, so you find the function based on your b value. What's the period? And you divide it into 4 equal spaces. And by dividing it into 4 equal spaces, you'll actually have 5 critical points down. So space 1, space 2, space 3, space 4. So you split up into 4 spaces. But more importantly, we have 5 critical points for every graph. So the last ones we've been doing, we went 0, pi over 2, pi, 3 pi over 2, and 2 pi. So we always wrote down 5 critical values. For every graph we do, you'll do 5 critical values. Okay, so we're going to graph all of these on this one axis here. This is an x and a y axis. So we're going to do sine of x. I'll do that in purple. Up 1, down to -1, 0, pi over 2, pi, 3 pi over 2, all the way out to 2 pi. And so remember, where does sine start? When x sine at the midline or 0 to a maximum, to a midline, to a minimum, back to the midline. So I'm doing just the regular sine function. We just graphed it over on the last example, and we're doing it again. What happens when I switch to 2 sine of x? What am I changing?
Slope. We'll make it.
What do we call slope when we talk about? It's not really slope anymore.
Stretch.
Yep.
Vertical stretch.
Look in the box. What is that called? Amplitude. Amplitude is how much you stretch above the midline and how much you stretch below the midline. So this is telling you to stretch 2 above and 2 below. So I've changed my amplitude to 2 now. And all that does is puts me up at 2 there and puts me down at -2 here. And so you can see a vertical stretch. Oh, I missed my dot. Watch what I can do. I can just put my dot there. Okay. when you switch the number out front, the little a value, all you're doing is stretching, or you might think of it as a vertical stretch. But it's how far above the midline you go and how far below the midline you go. So what's C gonna do? Go up half as much. So you're right in between here, right at 1/2 and negative 1/2. So you still calculate your table of values the same way, like the sine of pi, the sine of 2 pi, but then when you get your answers, you're multiplying by 2, multiplying by 1/2. So vertical stretch, vertical shrink. Now on these two problems, what am I changing? What letter, if you will? B, right? So in this case, my B value directly in front of x is a 3. So then the period of the function is 2 pi divided by 3. So it means it's going to go through the same look, but instead of being out to 2 pi, it's only going to be at 2 pi over 3, so it's going to get done faster. And my critical point then will be 2 pi divided by 3 divided by 4. Now for some of you, it might be easier, right, if we just go 2 divided by 3 divided by 4. Math, enter, enter. Or, if you're dividing by 4, you can multiply by 1/4, and you get 2 pi over 12, which reduces to pi over 6. So either way you do it, whether you do it on a calculator or you do it kind of mentally, you're spacing your critical points. When you see me write down CP, it's critical points, that's what I'm calculating, but it's really the space between. Okay, so the first critical point will be sitting at 0. How far do I space to the right? Pi over 6. How far do I space to the right? Another pi over 6. So what's 1 over 6 plus 1 over 6? 2 over 6. What's 2 over 6 when you reduce? Pi over 3. Add another pi over 6, or add 1/6. That's really 2 over 6. So what's 2 over 6 plus 1 over 6? 3 over 6, which reduces to 1/2. What's 3 over 6 plus another 1 over 6? 4 over 6. 4 over 6 reduces to 2 pi over 3. Now, when you take your last critical value minus the first critical value, it should always equal the period of the function.
Wait, so then
The last critical value, 2 pi over 3, minus your first one, minus 0, should always equal the period of the function. Now, some of you might have been doing this. 1 divided by 6, math, enter, enter. 1/6. Plus 1 divided by 6, math, enter, enter. I mean, you can just keep adding. Once you know what your critical points are spaced by, you just, on your calculator, can hit plus 1 over 6, plus 1 over 6, and math, enter, enter. Where does sine want to start? Where? It wants to start at the midline or 0. It'll go to a maximum, back to the midline, down to a minimum, and back to the midline. So the curve is like this. So I see the complete, if you will, complete sine curve. I'm not even close to 2 pi, right? How many of these curves will you see? If I'm done by 2/3, how many more can I fit in by the time I get up to 2 pi?
A quarter of it?
2 more. So if I multiply my b value by 3, I'm going to see 3 of the curves in the same amount of time as you would the normal periodic sine curve, right? Make sense? Okay. Cosine, what are we changing? The b value is 1/2. So what's the period of the function? What happens when you take 2 and you divide by 1/2? What do you get? 4. And then your critical points are 4 pi divided by 4, or every pi. So this time you'll be spacing the critical points every pi. So 0, 1 pi, 2 pi, 3 pi, 4 pi. I did not change the amplitude, so that's still 1 and -1. And now we're ready to graph. Where does cosine start?
Maximum.
At the maximum. So it's going to be at the top here, midline here, minimum, midline, maximum. There's 2 pi, right? How much of the graph do you see by the time you hit 2 pi? Half of it, right? By multiplying by something less than 1, now it stretches the graph. So some people do think of when you change the b value in terms of, is it a horizontal compression or is it a horizontal stretch? So, any questions on those 2 problems?